The Domestic Policy Review of Solar Energy was announced by the President on Sunday, May 3rd at Golden, Colorado. The President called for development of an overall national strategy to speed the development and the use of solar technologies. The Domestic Policy Review Task Force, representing 24 federal agencies, held a series of meetings nationwide, and more than 10,000 people participated. More than 3,000 testified. I'm Eddie Albert, and I'm going to introduce to you just a few of those people.
Many people have told us that this technology is impossible and still 50 years away. If someone tells you that, don't believe it.
The idea is to be as self-sufficient as possible and get away from the big systems that we can't control.
But there are enough people in it now who know what they're doing, who are building and installing quality products, and with the prospects of conventional fuel prices going up, the industry will make it.
Look, it will help all of us. It's part of our future.
It's the way we have to go for a lot of reasons. Not all of them are economic. Some of them have to do with the quality of our lives.
We're reaching our goals here in San Bernardino. It's not easy. It's not easy because I'm a woman and I'm black. But we have to do it.
There are a lot of exciting, creative solutions. It can be done.
That's quite a cast of characters for any film. You'll meet all of them and some others, and you'll discover that even though they may disagree on how to do it or when to do it, they all agree that it will be done. Now, what is this it that they're all talking about? Well, this it is important to me because nothing would grow in my greenhouse without it. It's the sun. And it's important to the people you'll meet here. A new breed of American pioneers who represent a sort of a new grassroots interest and awareness in this country that we can get a lot of energy from the sun in lots of different ways, and that the individuals, the tinkerers, the entrepreneurs can do it themselves. They talk a lot about what they're doing. We're going to hear what they have to say, but they also do a lot. And that's what this is really all about. This is an apartment community in Ventura, California, Ventura del Sol. It's heated by a hydronic system, hot water which is partially heated by solar energy. The man behind this system is Jim Piper.
This project is the largest residential solar system in the world. It consists of 254 units, 2 swimming pools, 2 recreation buildings, and 3 laundries. Interspersed amongst its 17 acres are 22 energy centers, like the one you see here in the background. Essentially, that's where the heat's put into the system, and the dwelling units and recreation buildings are where it's used or taken out of the system. Acceptance of the system in the building industry comes long and hard. The Department of Energy has done a study that says major changes in the building industry require 50 years. We're now into our 13th, and we've made some changes already. Here at our plant in Anaheim, you see the culmination of 13 years of development of the equipment used in our system. We manufacture nearly all of the components that are required to put the system together right here. As you can see, the manufacturing process is simple. If it wasn't simple, we wouldn't be able to do it. Essentially, that's because we've had no help from anyone. We've applied for grants and had those denied. We've applied for Small Business Administration loans and had the same thing happen. So we've done it ourselves. We've created jobs. We have 8 young fellows working in the shop here who were unemployed before they came to work for us. I've been asked continuously since I first invented the system, will it work anywhere? Currently, the system is in operation in 15 U.S. states, Canada, Mexico, Switzerland, Iran, soon in Argentina, and Australia. I think we've probably proven the fact that if it will work in Calgary, Canada at 40 below, it'll work anywhere.
Jim Piper is making a go of it in business terms. And here's a gentleman that knows all about that, too. He used to be on the building and selling side of solar systems. Now he's on the financial side as a vice president of San Diego Federal Savings and Loan Association. He's Peter Sardagna, and he knows some of the financial problems that folks face in starting up a new industry.
Okay, we at San Diego Federal, we pursue solar financing quite aggressively. We have developed one of the most innovative programs for financing single-family residence equipment. We're also promoting financing large tracts. As an example, we're financing for one developer some 500 homes, all of which will have domestic solar hot water heating. Most of these homes are solar heated to one extent or another. This one has solar domestic hot water heating. Others have total space heating systems in them. All of the systems are providing the amount of energy that they were designed for and are doing well. There are some problems, however, and they're mostly economic. Solar has a difficult time competing against conventional fuels that have received subsidies for years, or in the case of natural gas, that is artificially controlled and kept low. We look on the industry as just crossing the threshold of economic feasibility, and we think that these problems time will solve. The solution lies in the eventual raise of conventional fuels that will make solar competitive. The exciting part of solar today is that those systems that do work and those systems which are economically feasible result in something very beautiful for the homeowner. He can, at the end of the month, write a check measurably less than he did the month before the system was installed. That is exciting. That is news that will be spread, word of mouth, and that's how the industry will get off the ground. Systems that work is the key.
And there are other people all over the country that believe the future is now. People who are doing things on their own.
There's a wide variety of people in our research group. We have mechanical engineers, electronics people, physicists, carpenters, shipwrights. We've had the barge for 4 years now, and slowly we've been developing the renewable energy systems that will make this independent of outside energy sources.
Bjorn Lundy lives in Seattle. He studied at the University of Washington and is now an architectural designer. His project is under development on a barge at anchor in Lake Washington.
We've chosen a mobile floating facility so that we can move around to different environmental conditions, and so also that we can demonstrate that no matter what locality you're in, there's appropriate energy or enough energy right there, right where you are, to put together your own independent energy systems. We're also very interested in this teaching aspect. We've gotten a research grant from the Seattle City Light now to develop a study program for grade school children, teaching them about renewable energy. They're going to be the energy users in 1990, so we want to get them started recognizing some of these issues. Here we've built a solar glass wall which will passively heat the deck house. We have to finish closing the deck house in first, so we're still in the process. And then eventually we'll have some water storage drums inside here to hold the heat for longer periods. So this will be a part of a passive heating system for the deck house. Here we've got our model of a solar distillation apparatus for distilling fresh water, drinking water, from any kind of water, brackish. We could even use the bilge water. And what's coming out the nozzle down here is distilled water, and the energy used is just solar energy. We're studying how much water we can get out of this model over what period of time with this kind of sunlight. This is our windmill. We've put this together from renewed recycled materials. It's state-of-the-art technology with recycled materials controlled by the microprocessor computer. That generates the electricity for our house lights, anchor lights, all the electrical systems on board. We're really excited about our big parabola. Here's Cliff Cox is doubling as a foil applicator. Normally he's one of our computer experts. Here we see an example of using low-cost materials, aluminum foil, less than 2 cents a square foot, to achieve a really highly reflective surface. That'll be focusing the sun's energies on the focal point, and that's where we'll put our Stirling engine. The Stirling engine then will produce electric power. It's the way we have to go for a lot of reasons. Not all of them are economic or scientific, or a lot of them has to do with the quality of our lives.
This is a vertical axis wind turbine. In other words, it's a windmill. It captures the wind and converts it into electricity. Gardner Green and the people of his company in Laconia, New Hampshire, built this one. And they're building others for a living, for profit.
This vertical axis wind turbine was developed by a Frenchman about 50 years ago by the name of Darius. It attracted little attention until the energy crunch.
Gar Green is a successful businessman who has now turned his abilities to a new opportunity in the solar industry.
The world in the future. This is a scale model of an old farm windmill, of which they sold hundreds of thousands all over the country, primarily used to pump water because it's primarily a slow-speed device. And it, as you can see, has a tail vane to keep it oriented into the wind, whereas our vertical axis wind turbines don't care which way the wind blows and therefore are non-directional. One of the many advantages of the Darius is that it can be easily stacked. This is a new solar conscious plant in Clearwater, Florida. And as you can see, a triple stack Darius is providing 3 times as much power as a single stack unit would. We can actually stack many more than 3. This sketch shows 2 double stacks, each stack feeding its own alternator. And then where we have a prevailing wind, we can have power station array of stacked units. And there could be many, depending on the wind conditions. In the future, there certainly will be a large use of individual wind turbines in individual homes. At the present time, the equipment is a little too sophisticated, but as mass production is achieved and prices go down and equipment becomes more simplified, the many homes throughout America will be able to use the wind. Solar collectors and wind turbines go hand in hand. For when the sun doesn't shine, the wind usually blows.
The Energy Task Force is a private, non-profit group of architects, engineers, and educators who provide energy-related technical assistance to low-income people around New York City. We formed around the rehabilitation of this urban homesteading cooperative here at 519 East 11th Street.
Since the beginning of the industrial age, we have learned to rely more and more on technology. Ted Finch in New York City is trying to make technology work for the community on a human scale.
Realizing that long-term occupancy of the building is largely dependent upon reducing fuel bills, we showed the tenants how to properly weatherize the structure. Once this was accomplished, we showed them how to install a rooftop wind generator and solar hot water heating system to further reduce bills. As a harbor city, New York is fortunate enough to have some tremendous offshore breezes. We plan to utilize this natural resource with the installation of a wind energy conversion system. The wind generator will provide electricity to aerate these compost piles. The compost will be provided to community groups for vacant lot gardens. There's a vicious cycle at work here, but it can and has been broken through tenant ownership. What's exciting about what we're doing here on the Lower East Side with these solar technologies is that low-income people traditionally have not been on the cutting edge of developing new technologies. And with these installations such as 519 and at Quando, the low-income people have the opportunity to learn new skills in this developing solar economy. Quando is a neighborhood group of black and Hispanic youth who have built the first passive solar energy system here in New York City. This demonstration of passive solar energy is a wonderful example of appropriate technology in that youth from the neighborhood with almost no skills installed this system. It requires little to no maintenance, which is very important. From a purely energy point of view, it's much more energy efficient to rebuild the existing housing stock than to put up whole new structures.
They are pioneers, these people. There could be no more appropriate place for pioneers than here. The New Life Farm near Drury, Missouri, down in the Ozarks near the Arkansas border. Ted Landers is the driving force here. Educated in the East, he's lived in the big cities most of his life, until now. He and his family now live among the independent-minded folks of the Ozarks, and that suits Ted just fine.
My reason for New Life Farm is to try to bring low-cost technology to the people who really need it. If we're successful at bringing technology that works to these people here and that actually increases their standard of living for not very much money, then for sure it's going to apply in a more affluent farming community. This is our hydraulic ram. It's a pump that pumps water using no external sources of energy. There's no electricity that runs to this, no natural gas. The only thing that drives it is a spring that's up the hollow about 230 feet and is 12 feet higher than this ram. The 12-foot head that drives the ram pumps the water 150 feet all the way up to the top of the hill where the digester is. So it supplies all the water that the digester needs, all the water that the garden needs, all the water that the vineyard and the orchard needs, and all the water that the house needs. It'll pump somewhere between 1,000 and 3,000 gallons per day, depending on the flow rate of the spring. It really epitomizes the whole concept of appropriate technology. In the Ozarks and at New Life Farm, dual utilization of the land can be achieved by using hay for the biomass fuel crop and any number of different trees for the feed crop. The beauty of biomass is that it's a great way to store solar energy. In the New Life Farm digester laboratory, we take water, we take the hay, we could add manure or soybean vines, corn stalks, any other kind of agricultural waste products, and put it in these tanks. Out of the tanks comes methane gas, which is a very clean burning fuel which everybody knows affectionately as natural gas. Half the homes in the United States are heated with natural gas. Not only can we heat homes with it, but we can run gas refrigerators, gas hot water heaters, gas stoves, and we can even convert diesel generators to make electricity off of methane gas. The utilities currently have one big problem, and that is supplying peak demand. In the summertime at 4 o'clock, when everybody's got their air conditioners turned on, the utilities have to have all of their generators running in order to meet that demand. If many, many farmers had digesters that they could store up their gas through a 24-hour period, and then at 4 o'clock in the afternoon, or whenever the utility wants it, they could turn on their generators and supply electricity into the grid, it would solve one of the utility's most pressing problems. This facility here has allowed us to comparatively test 35 different configurations of absorber plates. We've used common materials, something anybody can get a hold of, such as beverage cans, plaster lath, aluminum roofing, etc. From our research, we've developed a low-cost, inexpensive collector and system that costs around $3 per square foot for the materials. We've had 5 workshops this last year teaching people in their communities how to build these. The workshops have been very successful. Somebody always ends up with a collector built on the house, and the rest of the people that come to the workshop go away with the knowledge of how to build it. We're trying to teach people how to take control of their lives.
Pioneers in pioneer country. Independence is what the New Life Farm is all about. But pioneer country is everywhere. And the frontiers of this expanding horizon of biosolar energy can be found lots of places in this country. Rudy Gunnerman chose Eugene, Oregon, because that's where he found millions of tons of waste materials that he believed could be put to use as a viable alternative energy source.
What you're looking at here is called Wood-X. It's a man-made fuel which is made from fibrous waste. That means anything that grows in nature, which the sun helps to grow, can be converted into a high-potency fuel, such as you see here in my hand. This is a renewable source of energy, and each ton of this product produced can replace 3 barrels of oil, or we generate the same BTU output per each ton of product or 3 barrels of oil would generate. Except it is not just renewable, it's also cleaner than oil because there's no sulfur in this product. We take fiber waste as it comes either from the forest or from sawmills or from the fields. We disintegrate it into powder or into powder form. Then we take the free water off, bring it down in a rotating drum dryer or any type of dryer to a moisture consistency of approximately 20%. Then we are taking it to a pelletizing process. It is a high temperature process where the temperature is being generated through compression and moisture. In this process, we then separate the lignits and waxes which are within a fiber product, using those as binders, and have the cellulose structure within this product free for combustion. In our own manufacture, we use about 10% of the BTUs produced in our own process. The waste in the United States are tremendously large. We have in excess of 1.5 billion tons of waste available. That does not mean that we can all use it, but if we could use the total waste, or close to the total waste, it would be enough energy to produce 20 quarts of new energy, or it would be actually more energy than we are today importing in oils.
All across the land, these American innovators are joined by their industrial counterparts, large and small, who are producing a wide variety of solar and other renewable energy equipment for the mass market. These combined efforts will have a major economic impact on the entire industry, indeed on the entire country. Yes, this pioneering spirit is found everywhere and in all kinds of places. An abandoned laundromat in San Bernardino, east of Los Angeles, is being used as a very special sort of shop, a place where they're building solar energy systems. One of the positive byproducts of any new industry is that new jobs are created. So it is with the Community Development Corporation, and the person behind this unusual project is Valerie Pope.
Here in San Bernardino, California, we're installing solar skylight water heaters. We're installing them on public housing for low-income people. The housing is owned by the county of San Bernardino. We also install same kind of solar hot water heaters on houses owned by the handicapped and other low-income heads of households. We see the solar industry as a new technology. It's an opportunity for the people here at CDC and people like us throughout the country, small backyard inventors, small businessmen, to take a chance at the all-American dream. It's an opportunity for us to invent solar systems that are unique and appropriate to the areas where we work. Developing, designing, and manufacturing, installing, and maintenance of solar systems are fairly simple. We have people in our organization that have some engineering background, but basically we're lay people. And if we can do it, most anyone can. Now we manufacture all of the components for our solar systems that we install throughout the city and county of San Bernardino. We not only manufacture the skylight solar hot water heaters, but we manufacture the flat plate collectors, which we sell to other solar programs. We attempt to give the people in training here a wide variety of skills in the energy-related fields. In our first solar project, we provided heat and hot water for 10 houses. We found that we had an excess amount of energy, and we decided to build greenhouses. We chose the hydroponic greenhouse for the first one in order to provide our trainees with an exposure to a new technology such as hydroponics. These are some of the plants that we grow here.
We did promise you an interesting cast, remember? They're interesting because they're doing something important, something you could be doing in the days ahead, because our government will be encouraging communities to expand solar energy programs. We can join the pioneers who are already learning to use wind or hydroelectric or biomass or the direct rays of the sun as another source of energy. The Secretary of Energy has said that there will be a great adventure for this country as we move into the next century and as we turn increasingly to renewable sources of energy as a replacement for fossil fuels. At the end of that great adventure, solar energy will take its place as a vital and long-term energy source. These small-scale, decentralized technologies have to be combined with energy conservation. If we can be more efficient, we won't have to produce as much energy, thereby helping the environment, reducing our dependence on foreign sources, and making our society far less vulnerable to natural or man-caused disasters. Decentralized energy technology is, by its very nature, community-based. Contact the people in your community who are pioneering this great adventure. For further information about alternative energy technology, contact the United States Department of Energy, Technical Information Center, Oak Ridge, Tennessee 37830.